Kinematics is the study of motion. In order to study kinematics, there are a few quantities that we can talk about. So now let's define a few things like position. And a position can be one-dimensional position, so you would have only an x, x initial, or a y final if we're only looking along the y direction. Or if we're looking at a two-dimensional position, it could be an xy pair on an xy coordinate system. So let's say that this is this is x and y, and let's say that this is 2 units and 2 units here. So then my position would be 2 in the x direction and 2 in the y direction. Then we can talk about distance and displacement. We usually use these two terms interchangeably in everyday conversation, but in physics, distance is a scalar, meaning that it only has a magnitude, whereas displacement is a vector. So it has a magnitude and a direction. So we write both of them as delta x, but for the distance, we just leave it as delta x. Displacement, we make it look like a vector, so we put a vector symbol over it. So delta x can be an x final minus an x initial, but for delta x for the displacement vector, we would have to use x final minus x initial vectors. So let's say that in one dimension we have an object starting at x1 and it moves to x2, and then let's say that it turns around and comes back to x3. So the motion is x1 to x2 and then x2 to x3. Now, if we want to know the distance that the object traveled, the distance would be x1 to x2 plus x2 to x3, the entire distance that the object traveled. The displacement, though, is delta x is x final minus x initial. So that would be the position, the vector that goes from x1 to x3. So that is delta x, just the shortest distance between the initial position and the final position. The distance traveled in this particular example is longer because you have to take into account the entire distance x1 to x2, and then to that you have to add distance x2 to x3. All right. Next concept will be speed and velocity. So speed is a scalar. So you can say that a car is driving at 50 miles an hour, whereas velocity is a vector. So that means that we know that the car is driving at 50 miles an hour north. So you know the direction that the car is driving in. So the symbol for both speed and velocity is v, and speed is delta x over delta t, whereas velocity is displacement, delta x over delta t. This equation is actually the average speed. I'm sorry, it's the average velocity, not the average speed. Let's get rid of that. So the average velocity. If we want the instantaneous velocity, then we're going to take the limit as delta t gets smaller and smaller, so it approaches 0, of delta x divided by delta t. And that is actually the definition of a derivative. So this is dx by dt. Okay? Now, in SI units, we measure distance and displacement in meters, and the symbol for that is m. And the unit for speed and velocity would be the unit for distance or displacement divided by the unit of time. So that would be meters per second. All right, now the next quantity that we can talk about is the acceleration. Now, acceleration does not have a scalar counterpart. Acceleration is always a vector. So the equation for acceleration is the rate of change of velocity, and that equation is for the average acceleration. The instantaneous acceleration, which we also write as a, I guess I can put an instantaneous here, is again a limit as delta v of delta v over delta t as delta t goes to 0. So that again is a definition of the derivative of v with respect to time, and the unit for acceleration is a unit of velocity, which is meters per second, divided by the unit of time, which is seconds. So the SI unit for acceleration is meter per second squared. All right, so these quantities, position, distance, displacement, speed, velocity, and acceleration, will be used in discussing kinematics in more in depth. And kinematics we can look at first in a one dimension, but then we can look at 2 dimensions and see how an object moves in both x and y direction.